In this question, we have an airplane traveling with a given ground velocity in a wind-free environment. Now, that's going to be one of our component vectors. And the plane encounters a wind, which is another component vector, giving an ultimate ground velocity, which is a resultant vector. What makes this question challenging is we have to realize that we have a component and a resultant, and we're looking for the other component. This isn't a situation with two components and we're looking for the resultant. We have a component that we're trying to determine, and then we also know what the resultant is. So it's a slightly different question. So what we do is we say, we know that the airplane is traveling at 320 kilometers per hour north 15 degrees west. So that's this right here, 320. And until the wind occurs, which moves it over to 340 kilometers per hour north 35 degrees west, right here. So taking all that into account, we have a magnitude of 320 and a magnitude of 340 with a 20-degree angle in between them, right there. And we can see that our wind is going to be in this direction, and we want to determine first of all this magnitude up here. So we can see that the magnitude is going to be 116.3 degrees. Now we want to know what this angle theta is here, but we're not going to use the sine law. The reason that we're not going to use the sine law is because we have three sides and we're looking for the angle in the we're looking for the biggest angle. Well, that's a possible obtuse angle, and so we're not going to use the sine law and get an answer that may be obtuse or may be acute, and there's a possibility that we won't know. So instead we're going to use the cosine law, and by using the cosine law we'll get the one and only one answer for that angle. So we can say that 340 squared is 320 squared plus 116.3 squared minus 2 times 320 times 116.3 cos theta. Solving it out for theta, we get that theta is approximately 89.7 degrees. So this is 89.7 degrees. Had we used the sine law, we would have gotten 89.7 or 90.3, and we couldn't have been certain which one was correct. So it's good that we used the cosine law and got only one answer. Now, we know that this is north 15 degrees west. So since this is 15 degrees, this is also 15 degrees. Now, this angle here is 89.7. Subtracting 89.7 minus 15 gives 74.7 degrees. So what that means is that this direction here is south 74.7 degrees west, which we have here. Now, generally speaking, the dominant cardinal direction is west in this case, not south. So we're going to restate that. Instead of stating it as south 74.7 degrees west, we'll say west 15.3 degrees south. So the wind velocity is approximately 116.3 kilometers per hour west 15.3 degrees south. Had we said south 74.7 degrees west, we would not have been incorrect, but it does look a little nicer to put it this way.